So if you've done any concurrency in Swift, you've probably used async let. And it's great, right? Super clean for running a couple of jobs at the same time. But what happens when things get messy? When you don't actually know how many jobs you need to run ahead of time? Well, that's what we're tackling today. We're going beyond that fixed world of async let and diving into a much more powerful tool, the Task Group.
Here's a quick look at what we're going to cover. We'll start on familiar ground with async let. Then we'll hit the wall, the dynamic challenge it just can't handle. After that, we'll introduce our main tool, the Task Group, see how it works, and dig into the nitty-gritty of results, errors, and cancellation. And we'll wrap it all up with a simple guide on when to use which tool.
Okay, let's kick things off with something we probably all know and love, async let.
I mean, you can't beat this for simplicity. When you know right there at compile time exactly what you need to do, like, hey, go fetch a user's profile and also grab their latest post. Async let is your best friend. You just define the tasks, await them, and you're done. It's beautiful.
And that's the key thing to remember here. Async let is designed for a static world, a fixed number of jobs. Everything is neatly contained in the scope where you define it. When that scope ends, Swift automatically handles cleaning everything up. But that very simplicity, that fixed nature, leads us straight to a problem. It's a big one, and it's something async let just wasn't built to solve.
Right. What do you do when you get a list of items from a server and you need to kick off a task for every single one? You have no idea if that list will have 5 items or 500. This is where async let hits a wall. You just can't write a loop and create async lets.
And this isn't some weird edge case, right? This is everyday stuff. Think about downloading all the photos from a gallery. Or a user uploads a zip file with a bunch of documents you need to process. Or you get a list of API URLs and you need to hit every single one. These are dynamic workloads, and you need a dynamic tool.
And this is where our hero, the Task Group, steps onto the stage. It is purpose-built to solve this exact problem of dynamic, unpredictable concurrency. So what is it? You can think of a task group like an empty basket. You create the basket, and then you can loop through your data and, on the fly, add a new task to the basket for each item. They all start running in parallel immediately, and your code won't continue past the group until every single task in that basket is finished.
Here's a really simple way to think about it. Async let is like ordering the #1 combo meal. You know exactly what you're getting. A task group, on the other hand, is like going to a buffet. You can just keep adding whatever you want to your plate.
And the pattern for using it is actually really straightforward. You open up a group using with Task Group, then you loop over your items and call add task for each one. And finally, you use a special for await loop to collect the results as they finish. Simple as that.
And here's what that looks like in practice. See that loop? Inside it, we're calling taskgroup.addTask. That's the magic moment. For every photo URL in our array, we're spinning up a brand new concurrent task to go fetch the data. It's happening in parallel for every single item.
Now, here is the proof that this is true concurrency. Let's say we have 3 download tasks. One takes 1 second, one takes 3, and the last one takes 5. The total time isn't 9 seconds. Nope, it's just 5 seconds, the time it took for the slowest task to finish. This is a massive performance win. Your app feels snappy, and users aren't stuck waiting for things to happen one by one by one.
Okay, so we've got the basics down. Now let's level up and talk about the details that really matter in the real world. How do we handle results? What happens when things go wrong? And how does cancellation work? First thing you need to know is there are 2 flavors of task groups. If the work you're doing is guaranteed not to fail, you can use the standard with Task Group. But for pretty much anything involving the network or the file system, things that can fail, you're going to want to use with ThrowingTaskGroup. And here's why that throwing version is so important. It has what's called fail-fast behavior. Let's say you're downloading 100 images. If the second one fails because of a network error, the group doesn't just keep chugging along trying to download the other 98. No way. It immediately cancels all the other running tasks and throws that error right away. It saves a ton of wasted time and resources. Okay, pro tip time. A task group has one rule. All its child tasks have to return the exact same type. But what if you need to fetch, say, a movie object and a TV show object in the same group? Well, there's a really clever trick. You wrap them in an enum with associated values. This way, every task returns a task result, but the actual value inside can be whatever you need it to be. All right, let's bring this all home. We've seen both tools, so how do we build a dead simple framework for deciding which one to use in our own code?
This table really breaks it down. The number one question is always, is the number of tasks fixed or dynamic? If it's fixed, async led is your guy. If it's dynamic, you need a task group. Also notice the difference in how you get results back. With a task group, you get them as soon as they're ready, which can be great for updating a UI piece by piece.
So here it is, the main takeaway. It all boils down to one simple question. Is your workload fixed or dynamic? If it's a handful of tasks you know about ahead of time, async-led is cleaner and simpler. If you're dealing with a collection of unknown size, task group is the only way to go. Getting this choice right at the beginning is going to make your code so much cleaner, more efficient, and way easier to maintain.
And just like that, you've unlocked a massive part of Swift's modern concurrency story. You now have this incredibly robust tool for handling some of the most common and sometimes most complex parallel problems we face as developers. The only question now is, what are you going to build with it?